Well, good morning and good afternoon to everyone. Welcome to the All Things Considered blower door. It's a little bit different than the tool time video that you just had the pleasure of seeing. So that was something that a lot of people have enjoyed, and we hope that you enjoy it as well while we get ready for our webinar. So we're going to start in just a moment. We have a few things that we need to cover. My name is Frank Spivak. I'm with the Energy Conservatory. I'm the marketing and sales manager. And need to cover a few housekeeping items. So if you're having trouble with any of the audio, then you need to click on the meeting in the navigation menu and choose audio setup. So for this webinar, it's only going to be through your computer speakers that you're going to be able to hear this. We do have an area for you to type in questions. Please feel free to enter those at any time. If we see something that might be appropriate to the topic that we're talking about right then, we'll address it, or we'll just save them for the end. This webinar is being recorded and will be available on our website soon, and as well on our YouTube site. And we would like to hear from you about other webinar topics. So if you have an idea, if after you see this, strikes you that needs to be covered, that you'd like to hear about, put it in the questions and we'll look at that for future webinars. We're trying to put on one webinar once a month, something that's going to be useful for you and be constructive. For this webinar, you will be receiving, those of you who are BPI, will be receiving one CEU. And we must reiterate that in order to receive CEUs, you must be logged in to the webinar using the same email address you used when you registered. After the conclusion of this, within a day or two, we will be uploading all the data to BPI for the CEUs to be awarded by them. So that will be done through BPI. If you have not provided your BPI number, now is the time to do it. So please send an email to editor@energyconservatory.com, include your full name and your BPI number. Hopefully that is enough housekeeping for you. So today in our agenda, we're going to be covering some of the basic components of a blower door. We always try to cover this so that people have a basic understanding of it, and we hope that it might provide you with a few more insights. We'll talk about the different systems that are available, the standard, the mini, and the multi. We'll go over the basics of an airtightness test, what it means, what it does, and how to perform that. And then we'll go into some of the other topics. So we'll talk about the ideas of pressurizing or depressurizing. What's the difference between those two? Why should I pick one over another? And then we'll also cover other kinds of tests that can be done with a blower door setup. And these are duct leakage testing, the idea of trying to find out how much the dryer or the kitchen exhaust is actually producing, how much air is being evacuated because of those two items. Today, in trying to measure those, it's very difficult to try and put a capture hood over a dryer. And with some of the kitchen exhausts, the way they're constructed, then it's difficult to put some sort of device underneath it between the hood and the range top itself. And some of them actually have quite a lot of airflow. So we covered a way for you to do that. So the basic components of any blower door setup is that you have a gauge that's going to be reading pressure and translating that number into cubic feet per minute. A fan that is going to be generating the flow, and that you're actually able to measure the pressure difference across that fan. the frame, which goes into an appropriate doorway and holds up the frame, holds up the fan, and tubing and a panel. So the basic components, so here we have the DG700 pressure and flow gauge. Any pressure and flow gauge can work because it's measuring differential pressure. So in the case of our DG700, we have two channels that are available. They read simultaneously, so that on the left-hand side, we're reading building pressure, and on the right-hand side, we're measuring fan pressure. The fan pressure is then converted to CFM or flow, because through the process of taking a test, you're going to be entering the device that you have, whether it's a Model 3 fan or a Series B fan, the configuration, which is it open, ring A or B, ring 1, 2, or 3 on the Series B duct blaster fan, and we're calculating the CFM through that known size of opening. And then proper tubing connections for the gauge are always critical, both going to the outside as well as to the fan. Now the Model 3 fan is certainly our standard item that we've been making for many, many years. Generates about 6,300 CFM of airflow. And with that fan, it includes the fan speed controller, ring A, ring B, and a no-flow plate. It's a very durable housing. We have fans that have been around for, that go back to the mid-'80s when this current housing design style was first adopted. Now, ring B is included and allows the user to go down to 300 CFM. That's a very small amount of airflow, but we have customers who are using it for more stringent testing measures. So ring C, D, and E are options that can be purchased at any time. Ring C will bring you down to 85 CFM. Ring D will go down to 30 CFM. And ring E will get you all the way down to 11 CFM. The frame and panel. So we have been making a number of improvements over the years to the aluminum frame. And for about the last 6 years, the current aluminum frame with the flexible gasket on it has been sized to the point where the largest door width is 45 inches and the tallest height is 96 inches. So occasionally we will get a question from people of, how do I measure, how do I put my blower door in a house that has an 8-foot door? Well, if you've bought the blower door in the last 5 or 6 years, you're already set up, because the panel has been sized to be able to be placed in a 8-foot door, as well as a 45-inch door. There are additional frame and panel combinations which are available for other specialized activities. We have some that are as wide as 48 inches, which is being used in areas such as fire safety testing or clean room testing, where you have an extra large door because they're bringing things in that are oversized. But our common standard system includes a frame and panel that'll go to 45 inches wide and as high as 96 inches. So the smallest door is going to be 28. So you can do a 30-inch door if that's the case, but most entryway doors are going to be larger than 30 inches. And you need tubing. And some people need lots and lots of tubing. So when you have a kit, our standard system includes a red a green, as well as a clear tubing for extra measurements that you might want to do. We use the green tubing as a longer tube because we've tried to use the designation that green tubing equals grass. And so you should use the green tubing to go out to the outside as your building pressure measurement. And the red has been used to connect the fan to the gauge. So green to outside, through the door panel, and out. Green to grass is an easy way to remember that. And there are lots of other colors and size options available for people who might be doing zone pressure testing or combustion appliance room testing. So all of those are available at any time that you might need them. One of the critical things about tubing is that you need to make sure that there's no leak. I was in a recent was talking about this concept, and so somebody wanted to see a picture of it, and I think they were joking around. They wanted to see me doing this kind of. So you see on the left-hand side that one end of the tubing is being held closed with the thumb, and the other side is being sucked on and is sticking to my tongue. So the idea is that if it's able to stick to your tongue for 5 to 10 seconds, then the tubing has no leak in it. If you can't get it to stick to your tongue, there's a leak somewhere. It could be that there's a crack on the end of the tubing, and all you need to do is snip off an inch or so of the edge. And sometimes you might actually have a pinhole elsewhere, in which case you might want to just replace the tubing. But that's the most important part of our measurement system in being able to transfer that pressure value from the fan through to the gauge, or from the outside and through to the gauge. So what kind of systems? Our standard system, mini system, and multi-fan system. The standard system, with all of the standard components that you see there, is our Model 3 fan, and it does go up to 6,300 CFM of free air, but when you add the back pressure of doing building testing at 50 pascals, the limitation is about 5,300 CFM per fan. The most common uses, of course, is residential building testing. This has been used since the start of the company. That's been our basis for being in business. With having the range up to 5,300 CFM, it's also able to be used for small commercial buildings. So many site-built locations where it's an individual store, and they might have 3,000 to 7,000 CFM of floor space. It can be a useful device and be used in those situations. You can take a single fan and use a number of them together. So for example, if you have a large home that has a complex kind of structure, but you need to put one blower door fan on the east side of the building and another blower door fan on the west side of the building, it's just easy enough where you can add the two values. Both fans are working, and they're giving you different. All you need to do is add those two together. One of the things that we're seeing become more popular is the use of our mini blower door system. And in this case, we're using the Model B or the Series B fan, which is typically used for the duct blaster system. We can get up to about 1,350 CFM at 50 pascals. You're still using a standard blower door frame, but we're using a different door panel because it has a smaller hole in order to fit the duct blaster fan. The additional door panel is about $150 to $160. We're seeing it being used in places where individual apartments are being tested. Since apartments are rather small, 1,000 square feet is pretty big for an apartment. It makes it very convenient. It's also much lighter weight, so you're able to just loosen the frame pieces, take it out of one door of an apartment, and then move it to another apartment. We're also seeing it being used for passive house. There's the housing stock that's being built. Passive house is still an extremely small percentage of homes being built, but we're seeing more and more of them being constructed and pretty much all over the United States. So passive house systems could easily use the mini system. New homes that are expected to be less than 3 air changes per hour, or maybe have less than 3,000. Hello, 1, 2, 3 testing. I think the sound is back now. Sorry about that, folks. Something happened where it disconnected. One of the questions that was asked is, what's the maximum size house in square footage for a Model 3 fan? The universal answer is it depends. Depends because the most important factor is how leaky is that house. So, for example, a small house, say 3,000 square foot, that is really, really leaky, you may wind up maxing out the fan because there's so much leak, even though it's a small house. On the other side of it, you might be in a house that's a McMansion and you've got 5, 6, 7,000 square feet, but it was constructed very well. And in that case, a 6,000, 5,300 CFM of a Model 3 fan might be very adequate because you may only be reading 2,500, 3,000 CFM of leak on a house that size. So there hasn't really been a guide of how much the maximum house size is. We generally try to use the rule of thumb of 1 CFM of leak per square foot of house tends to be a moderate construction. So in that case, you could make an estimate and say, well, I'm going to be testing 3,000 square foot houses, and for the most part, you're going to be using ring A, the low end of open fan, and reading 3,000 CFM. Multi-fan systems. These are really more for things like large multifamily residential buildings where the entire envelope needs to be tested, or for medium and large commercial buildings. So we do have 2-fan and 3-fan kits that have all of the various tubing connections pre-constructed for you. Multi-fan systems, we generally recommend using Techlog 3 to control the fans because it provides a much better way to control each of the fans. You can turn on and off individual fans, and you get a real-time report of what the airflow is over time. Now, when we're doing and working with buildings and we're trying to work on commercial buildings and large residential, multifamily residential buildings, we're generally reading at 75 pascals. Because the buildings are either taller or bigger, the general idea is that they might have a little bit more stack effect. And because of that, we want more air, more pressure on the building to give us more reliable numbers. So when we take a standard Model 3 blower door fan and measure at 75 pascals, our maximum flow is about 4,800. So those that might be considering doing some commercial testing, you need to take that into consideration for how many fans you need to bring to the job site. So basic air tightness test. The basic concept here, as shown in the drawing, is this box can represent the house. If the box closed on all 6 sides, no air would be going in or out. But because there's some sort of leak, and the idea of how pressure measurements to airflow works is that when there is a leak or an opening, air will move from high pressure to low pressure. So as we put a fan in this box or house, we are depressurizing. So we're making the pressure inside the box a little bit less than the outside. And so airflow will move through those holes or leaks in a very predetermined fashion. So what we're trying to do is we measure how much pressure is being induced in that box. We then combine that with the measuring the pressure across the fan to get us the CFM. So it's a very basic concept. So when people go out, especially for home performance contractors, if they go out to a homeowner and try to explain why they're doing a blower door test and what it's going to tell them, this is a really nice diagram in very simplistic terms to talk about what's going on with the test. This next picture is a way to identify or show people where those leaks can occur, especially when there are older homes and a lot of things like these attic hatches and bypasses around chimneys, a lot of recessed lights, crawl space, basement, all these various penetrations. This is an excellent diagram to show how air is moving in or out of a house, even without a blower door being attached to it. The general dynamics of a house, because of its own stack effect, or wind outside, or pressure differential, temperature differential inside to outside, can cause a lot of this air movement throughout the building. So taking what our diagram had a couple slides ago, here's the basic principle. We place the blower door fan at an appropriate door. We want to make sure that the doorway is from obstructions. So generally that becomes an entry door. As we are drawing air out through the fan, it purposefully brings air in through other parts of it. So if we're measuring at 50 pascals, and the idea of the measurement or the pressure across a vessel, meaning the house, is going to be relatively uniform. So when we measure at 50 pascals at the front door, we're fairly certain that we're getting 50 pascals throughout the rest of the structure. When you have more complicated construction techniques, that can cause problems, and that's why we do want to measure pressure in various locations. But in general, for most testing, this simple diagram explains what's going on. So we adjust the fan higher or lower speed in order to get the 50 pascals, and then we measure that flow. That flow is then deemed CFM 50. So hopefully that gives you the general overview. Let's talk about some other issues that come up on a fairly regular basis, such as pressurize and depressurize. What's the difference? Why do I want to do one versus another? So pressurizing a building. So when we're pressurizing the building, we're taking the fan at the front door and we are facing it so that air is pulling from the outside and going through the fan into the house. When it does that, it's actually pushing all of the contaminants out, which is great. So if there are attic leaks or garage leaks or crawl space leaks, pressurizing the house is really beneficial because it is pushing that any potential of dirt and dust and contaminants out rather than bringing them in. It's also really useful for things like a fireplace or a wood stove. Instead of having to seal off extremely carefully the fireplace so that ashes don't get distributed around, then doing a pressurizing is a really great idea, especially when the client has a white rug right in front of the fireplace. A number of people have told me their stories of depressurizing without emptying out the firebox and having to pay to get that nice white carpet cleaned. One of the things about pressurizing, it does open up a lot of the gravity dampers that are in the house. So for example, a dryer vent, a kitchen vent, or a bath vent, those going to the outside, those are normally in a closed position, and when the dryer or kitchen vent or the bath vent turns on, a little flapper door winds up opening and pushing out the air through that. So when we pressurize, we take all those different openings and we then are pushing those out. Now those are normally closed, so what happens is that the number that you get when you pressurize the house is going to be slightly higher than it is if you depressurize the house. The other thing to remember is that when you're pressurizing the house, you're bringing in that outside air. So in places where it's moderate temperature outside, moderate humidity, then bringing in that outside air through the front door in large quantities, because we're talking about bringing in 3,000 cubic feet of air every minute that the test is running. So you want to make sure that when that air is coming in, that it's not a burden to the people that are actually inside the house. The other thing too is you now have a steady airflow stream. So you might want to make sure that the homeowner doesn't have any papers in the vicinity because all of that is going to be blown around once the fan gets turned on. Depressurizing. So same concept, but just backwards. So when we're depressurizing the house, we're taking all of the air that's inside the house and sucking it out. So when we do that, it is bringing in airflow through the attic and garage and crawl space. And if those have a heavy amount of contaminants, then that is probably not something you really want to do. Generally, though, those openings are fairly small. So it's not like you're going to be bringing in huge amounts of things, but if the homeowner is potentially allergic to various substances, you probably don't want to do a depressurizing. Also, when you are depressurizing, if there is a fireplace or wood stove, it should be cold. Otherwise, you're going to be bringing those combustion gases back in through the house. Now, it also, because you're depressurizing and you have the gravity dampers already in place, those wind up getting snugged tighter. So the house will be a little bit lower on a CFM basis when you compare a pressurized to a depressurized test. So bear that in mind. So a lot of people will use a depressurization test, especially when it's hot or cold or really humid outside. Again, when you're bringing in the air through the various openings around the house, by the time it gets to many of the occupant spaces where you're doing the test, that is it's getting tempered by the surrounding air. So the surrounding air will make those cool or hot or humid airflows more moderate as they move through the structure of the house. There was a question of whether there's a way to seal the dryer, kitchen, and bath vents. So when you're doing a pressurization test and you want to go around to the house, let's go back here one slide, and you want to take those out of the equation, well, now you have to walk around the house and find those vents, especially some of the bath vents that are going to be on a second floor. You may have to be crawling up on the attic, which is another reason why a lot of people will just do a depressurization test, so they don't have to go around closing all those gravity vents for a pressurization test. And the simplest way to do that is to just tape those closed. Painter's tape, masking tape is a really easy, simple way to do it. You are outside, and so they may have some grime around them, so the tapes may not stick as well as you want, but you're only going to be doing the test for a short period of time. So now here's some of the fun stuff, and this is what I want to talk about with other kinds of tests that we usually don't cover in webinars. Sometimes we do in short bursts, but hopefully we can have a chance to talk about these more and be able to answer some of your questions. So we have a duct leakage test, a couple of duct leakage tests, and a way to measure the flow through dryers and kitchen vents. So we'll show you all of these different testing methods. First, on duct leakage. Using a pressure pan. Now, a pressure pan was designed many years ago as a way to have a seal and only one outlet or one way to get pressure with the pressure port on the top of the pressure pan. That's connected to the gauge, and as soon as there's any pressure differential on the other side of the pressure pan, then it will be registered on the gauge. The pressure pan method of duct leakage testing is strictly for duct leakage to outside and is a way to determine the severity of a leak or the location. It will never be able to give you a CFM value. So pressure pan values are just more of a qualitative nature instead of quantitative. The pressure pan then is placed over the register, with the house being pressurized or depressurized to 50 pascals. When you do this, if you have the luxury of having two separate gauges, you'd want to set the gauge and fan to cruise 50 for the house. Then that allows you to take the gauge around to the various registers and measure how much pressure there is at each one. If you don't have two gauges, what you would be able to do is manually adjust the building pressure to 50 pascals, then disconnect the hoses, disconnect the fan speed control, and carry around that original gauge in the various locations. When we're going around the house and now the gauge is in pressure mode, we're looking for any kind of value other than 0. Ideally, we're looking for 0. 0 meaning that there's no leak between the inside and outside. Because remember, we're pressurizing or depressurizing the house at 50. If we see 0, that means there's no leakage from one spot to the next. as we go from register to register, what winds up happening is that if the register is connected to the outside, and there are a number of registers along that trunk, you're able to read the pressure values as you move along that trunk. And when you move along that trunk, when you get to the highest value, then that tends to be the leak, the most dominant leak to the outside. So all we're trying to do is find the different values, find out what those pressure values are, if there's anything there, and then track that down and use that as a way for people who are then going to finish off the job and finish the air sealing project when they get to the rest of the ductwork. So again, it's the kind of thing that is only qualitative. Are we getting a leak? Are we not getting a leak? And we're looking for values. And in some cases, even a pressure value of 5 pascals is going to give you an indication that, yes, this is where my duct is leaking to the outside. It's a very simple test and can provide some really useful information, but just understand what the limitations are. Now, this is a test, blower door subtraction. This is a little bit different in that we're trying to get a quantitative value. How much airflow is there moving through ducts that are leaking to the outside? And you're limited by the fact that you just have a blower door and a gauge and some masking tape. So it's a kind of a 3-step process. The first one is performing the whole house test just as if you were doing a regular rating to find out what's the leakage of the house itself. The air handler's off, windows are closed to the outside, doors are closed to the outside, doors are open on the interior of the house. The next step is to turn off the fan, tape off all of the supply and exhaust registers in the house, wherever they might be, basement, living room, bedrooms, sealing off each and every one of them. Then performing another blower door test. In this case, we're calling it an envelope only test because we're closing off the registers. So the idea is, what's the difference between the house with the registers open and then with the registers closed? When you're doing the test with the registers closed, we also want to measure what the pressure is in the ductwork when you're taking that test. So we're putting the house at 50 pascals difference, and we want to measure the pressure that's inside that closed duct, either at the register that's closed or sealed, or in the ductwork. Either way, we need to find out what that number is. Then we're going to go through a process of subtraction, correction factors, and multiplying out the results. Now, there can be a wide variation on the accuracy, but if you have no other tool to do a measurement, blower door subtraction can get you in the ballpark. In our blower door manual, there is a subtraction correction factor table. So you can see that on the left column, it has the pressure values of the ductwork with all of the registers taped off. And on the left pair of columns, we have 50 down to 31, and the right pair of columns, we have 30 down to 11. If you can't get 10 pascals of pressure, then it's pretty leaky. So 50 pascals, there really is no correction because there's no leakage. There's nothing there to work with. So when we get down to any of the other numbers, we want to look at this table, find out what that value is, and remember and write that down. So let's go through an example of what that means. We want to calculate the duct leakage, so we subtract the envelope only result from the whole house result. We then we find our pressure value from the correction factor table and get that number, and we multiply the results. So here's the example. Our house is, say, 3,000 CFM as a whole house before we've closed off any of the registers. We close off all those registers, do the same test again, and we get 2750. So we have about 250 CFM of leakage as our starting point. But we want to find out what's the duct pressure value. And so in this case, our example is 45 pascals. And when we look at the table, we see that that correction factor is 1.29. So we take that 1.29. So we find our difference. We multiply the difference between the whole house test and the envelope only test, multiply that by our correction factor, in this case 1.29. So our result is 322 CFM. So 250 times 1.29 equals 322 CFM. Now, when I say that this has some variability to it, we're doing an estimate of duct leakage without really measuring duct leakage directly. So there is a range of values for that number. So the repeatability accuracy is generally plus or minus 3%. But when we do that plus or minus 3% and we multiply that out, because we take 3% of 3,000 CFM, and we multiply that, 3% of 3,000 is 90, we multiply that by 1.29, we get 116 CFM. So the flow through the ductwork leaking to the outside could be anywhere between 206 and 438 CFM. Our mean estimate, our standard number, is 322. So even though it has an accuracy of 3%, because of this correction factor, it actually makes it a much larger number. So again, it's an estimate, and it's just a way to give you another working tool to get more information about the house. There's a question again about how did we get the 45 pascals. So when we do our test, I'll go back a couple of slides. When we have the house pressurized again and all of the registers are sealed, all we do is take a pressure hose, punch it through into the ductwork or in through the register sealing tape into the register. And we measure that on the gauge. And that gauge is reading the pressure difference between what's inside the ductwork and what's inside the house. So all we're doing is taking the input value, the hose from the register, connecting it to the input side of channel A, where we're reading pressure, and measuring that Pascal value. Hopefully that answers your question. Another way to measure duct leakage is, again, by taking the blower door. And in this case, what we're going to do is we're going to seal off all the supply and exhaust registers as we did in the previous test. But we're going to leave the largest register open, the one that's the closest to the air handler. We want to keep that open because we need some way that all of the airflow that's funneled through there, because the house has been pressurized, we want to measure it, we got to get it to one location. So in this case, we're going to use a capture hood. So the capture hood is going to be measuring the flow through that register. And whatever the flow that's being read, on that gauge translates into duct leakage. Still need another piece of equipment in order to do this, but if you don't have a duct leakage fan and test, then this is another way to do it. So we're pressurizing the house and we're leaving one access point open, meaning the largest and closest register to the air handler, and then measuring all the flow that's being funneled through that. It's a different kind of concept, but one that is being used out in the field. So I wanted to make sure that you saw that. We're going to move on to another topic. Blower door pressure matching. Many of you who might use a duct blaster are familiar with the pressure matching method. The idea is that we're going to add air into a system to match the air that is leaving because of mechanical ventilation. So commonly it's used for HVAC systems to determine the total amount of airflow through an air handler. The air handler is actually sucking air out of the house, in a sense, and pushing it through all the registers. So if we're able to match that flow by connecting the duct blaster to the air handler, then we get a very accurate measurement of how much airflow is moving through that air handler. This case of doing a blower door pressure matching method is really the most accurate if the exhaust fan depressurizes the house by at least 3 pascals and the wind is fairly calm. When you get into 1 and 2 pascals, that's not really a lot of pressure differential. And it also means that maybe you have the fan that's running, but the house is leaky enough, but it's not depressurizing the house enough. Also, if you're dealing with smaller ventilation value, then you need to use ring C, one of the optional rings for the blower door, because the ring B will only go down to 300 CFM, ring C gets you down to 85. Now, if you're doing bath fans, and some of those might be at 40, you know, there's other ways of doing it. You can use an exhaust fan flow meter and some other devices. This is just another way of doing it for the more difficult things like air or kitchen exhaust. So when we're doing this, we're going to set up the blower door to actually pressurize the house. When we turn on the mechanical ventilation system, it is depressurizing. It's pulling air. So what we want to do by pressurizing to match that pressure, we're going to be adding air in through the blower door fan. Now, because we're pressurizing, one of the things that we need to know is an outside reference for the fan itself. So normally there's just an outside reference that's on channel A, and that goes to the outside. You would take a T that's included in your pressure kits and make a T where you're connecting both reference for A and B to get a proper reading. Now you can manually adjust the fan, or you can use the cruise function. And I'm going to show you how to do that with the cruise function. So dryers, they come in all kinds of different sizes and values, and how much air is, is being sucked out and drawing out all of that moisture. In addition to that, there's stack issues. Sometimes the dryer is not working properly because the stack is clogged up. There's a lot of lint inside it. Could be inside the dryer itself. So those are all issues that are related to that, essentially that mechanical ventilation system. So in order to do this kind of test, we're going to place the door for pressurization. Again, remembering that we need a hose that's going to do outside reference on both channel A and B. We want the blower door fan closed off, so we want the rings on there and the no flow plate. Or if you're doing it from the inside, you just want to put a large piece of fabric over the entrance of the blower door. Because what we want to do is get a baseline. We want to find out what the baseline of the house is. So we hit baseline and start. We let the gauge run for several seconds. Press enter. That's going to lock in the baseline of the house. Now we take off the cover of the blower door fan and we turn the dryer on. We want to make sure it's only on air. We're not heating it. So most dryers have an air function where they're just doing the unconditioned air. And we want to set the gauge to cruise -0. And we measure the flow through the fan. So we set the gauge to cruise 0, tell it to start fan. And as air moves through the fan, what's happening is that we're maintaining the original baseline of the house, even though we've got mechanical ventilation taking place that's depressurizing the house. So we're adding air in so there's no difference from when the house started, our baseline. The amount of air that's going in to make the house basically 0 is how much air is moving through the mechanical ventilation, in this case the dryer. So this is an advanced concept, but it's a fairly easy kind of test. And we'll go through this again as we talk about the kitchen exhaust. It's the same principle in action. So let's move over to kitchen exhaust. So here's just some examples, some of them really artistic, some of them functional. Well, I guess they're all supposed to be functional, right? But how they go together, the volume of air, some of these are the super sucker types of things. Sometimes the ranges have an exhaust fan built into the range. So as the smoke comes off of the range itself, then it's being sucked through there. So how are you going to actually measure that airflow going through there? So the process in this case is exactly the same. So we're placing the door in the front door and doing a depressurization. Tubing is going to the outside and connected to gauge channels at A and B, and the blower door fan is closed. And then we press baseline. We have one of the questions here concerning the baseline. So if I put a cover over the inside for baseline of the house, the pressure tap is on the wrong side. Pressure tap is on the wrong side. No, that's not the case, because what we're trying to do for the baseline is channel A. And A is using the green tube, and based on our earlier description, the green is grass. That green is going to the outside. So we're measuring the baseline with the, essentially we're trying to close the door and measure the pressure across there. What is that airflow? So hopefully that answers your question. Another question was, how critical is it to perform the baseline to the manometer before running a test? This is just giving you an idea. Sometimes the baseline could actually be 0, in which case baseline isn't important. What we're trying to do is give you a number to start with. The baseline 1, excuse me, could be +1, could be -1. And just to avoid any of the math, running the baseline is a useful way of doing that. Pardon me. Another question, would the gravity vents on other exhaust fans affect the results of the dryer test? Well, you're depressurizing, excuse me, you're depressurizing the house. So all of the gravity dampers are actually being sucked closed. So those gravity vents gravity vents would not really be affected very much. So again, with a kitchen exhaust, we're doing a pressurization, doing a baseline. The baseline could be very well 0. We let the gauge run for several seconds, turn off the blower door fan, turn on the kitchen exhaust, take the cover off of the blower door fan, turn on the kitchen exhaust, set the gauge to cruise -0, and we're measuring the flow through the fan. It's a simple kind of test that can tell you a lot, as long as you understand the principles around it. So exhaust fans depressurize the house. We want to add in airflow to make that difference between the inside of the house and outside of the house. Another question, how about the idea of measuring kitchen exhaust by using the blower door to depressurize to the house to the same pressure created by the range hood? That's exactly what we're doing. But if you're depressurizing with the exhaust pressurized with blower door, then pressurizations and not solving the issue. We need to pressurize. We need to add in airflow with the blower door fan to equal the air that's going out through the, again, the range hood or the dryer is exhausting or depressurizing the house. So we want to add air back in so that there is no depressurization. So the amount of air that's being added to eliminate the depressurization, that means now we know exactly how much airflow is moving through that fan of the blower door. That's the same amount of airflow that's moving through the exhaust fan. And it doesn't matter whether it's a dryer or kitchen exhaust, or even bath vents or any other kinds of things that are taking place. So that's our webinar for today. Be happy to answer any more questions that you have. We covered just some basic issues that are related to what's going on in the house. Let's go back to a couple of questions that came in. One of them was, what if there's vermiculite present in the attic? Generally, vermiculite is solid and doesn't have anything coming off of it. It's as long as it hasn't been disturbed. So generally, and I believe that a number of years ago, the Canadian Mortgage Institute did some testing of vermiculite. What happens? Do the vermiculite particles come through? They concluded that the risk is relatively minor, but that they still did recommend doing a pressurization test of the house. So vermiculite is present in a number of houses from the middle 60s. So you want to be conscious of what's going on there. Another question, is there a standard action number in Pascal where duct sealing becomes a recommendation? Basically anything other than 0. When you're doing a pressure pan test and you are depressurizing the house or pressurizing the house, measuring that differential across then that value means that there's leak. If it's 0, there's no leak. So the action number is anything above 1 or 2 generally is what people are recommending. And beyond that, then you really need to start sealing ductwork. I'd like to know how to use the Airtightness software just for blower door testing on new construction. That is a suggestion, I think, for a future webinar. We'll get that included. Let's look at some of the other questions that we have here. webinar is being recorded, and it'll be present on our website and on our YouTube channel in just a few days. So you'll be able to see that. What is the uncertainty of the dryer and kitchen exhaust test procedure? This doesn't have the same kind of variability as the blower door subtraction, because we're trying to use a device to get a value that is not normally used. We're not doing an immediate direct measurement. But the blower door system is plus or minus 3%. So when you do this exhaust test, and you're doing the pressure matching, then you can rely on just the plus or minus 3% of the individual. If you have an exhaust reading of, say, 200 and another question. When testing kitchen exhaust airflow, should input tap be connected to the house to a hose to the kitchen, or just measure pressure by the blower door? I think the question there is that when we're reading the pressure of the house, because the exhaust of the kitchen hood is running, the pressure is equally distributed around the house. So we're measuring that at the front door, just as if it were any other place. So the place where you want to measure it is not necessarily in the kitchen or around there. It doesn't matter. It's wherever you have the blower door, because you want that building pressure along with the fan flow measurement. So the idea is you're just measuring the pressure across the blower door area, or the blower door panel. And I think we've answered all of the questions that I have here. If you have more questions, please feel free to send those in. You can send those directly to me, or you can also visit our support forum for posting a question there, our website at energyconservatory.com. With that, it concludes our webinar. We really thank you for being here today, and we have more coming up next month, and I believe that Paul Morin is going to be doing some commercial blower door testing webinars to give more people some direct information on how to use our Beyond Residential manual on how to do commercial testing. So with that, I want to thank you all for being here, and look forward to see you at the next conference, trade show, or webinar. Thank you.